Hi,
Hello,
I'm James,
and I'm Robert.
and today we're going to go over matrices. A matrix is an array of numbers of the following form. An m times n matrix has m rows and n columns. For example, the following matrix is a 2 by 2 matrix.
If m equals n, then the matrix is square. Another form for a matrix is where A is equal to Aij, in brackets, where Aij is the value at row I and column j.
Are there any specific types that I should know about?
As a matter of fact, yes. The zero matrix, where all the elements are 0. An upper triangular matrix is a matrix where, for I greater than j, Aij is equal to 0. A lower triangular matrix is the other way around, where if I is less than j, Aij is equal to 0. A diagonal matrix has 0 values for all ij when I is not equal to j. Then there's the identity matrix.
So the identity matrix is a diagonal matrix where all the numbers on the diagonal are 1.
Exactly.
Cool. Now we've got the basics down, let's move on to actually doing stuff with matrices. To add and subtract matrices, they must have the same dimension, which is a fancy way of saying they must have the same number of rows and columns as each other. Addition and subtraction work exactly how you'd expect. Simply add or subtract the values in the same positions in the other matrix.
On to multiplication. To multiply by a scalar is straightforward. Every element in the matrix is multiplied by the scalar.
Simple, really. If we multiply the matrix by 2, everything inside it doubles.
Multiplying a matrix by another is a little more tricky.
Yeah, how do we do that?
So, first, let's say that A and B are m by n and p by q matrices. A times B exists only if n is equal to p. To find a term in the new matrix, we look at the relevant row from the first matrix and the relevant column of the second matrix. If we multiply each value in the chosen row by its corresponding value in the chosen column, then add all these products together, we get our term in the new matrix.
So how do we know which columns and rows to choose?
Let's use the first example to explain. We have two different matrices. To find the first term in our new matrix, we choose the first row of the first matrix and the first column in the second matrix, as the term we are trying to find is in the first row and first column. Similarly, the second term in the top row we find by choosing the first row of the first matrix and the second column in the second matrix, as the term we are trying to find is in the first row and the second column, as you can see by following the colours.
As we can see by the second example, where we have the same matrices, but we have multiplied them the other way around, multiplication isn't commutative for matrices, i.e. A times B is not necessarily the same as B times A. And that's the end of this video. Join us next time when we go over inverses and determinants of matrices.
See you there.
Bye!